thank you everybody for coming tonight. It is quite an honor and a privilege to be invited to speak with you. And I am so excited to give this talk because not only will this inform you, it could transform you. You could leave this room as bold as a lion. You'll realize you got PhDs on your side, you got a professor of aeronautics from the Air Force Academy on your side, and you'll be able to walk into the science departments at St. Cloud State and say, hey, would you like to look at a theory that's making accurate predictions? And I know you can do it because that's what I've been doing. And just to lay the backdrop for this talk, last month I spoke out in Colorado at the Rocky Mountain Creation Fellowship and Pikes Peak Creation Fellowship and a church. And on the way out there, I spoke twice in Nebraska. And while I was out there, I was interviewed by Real Science Radio. And yeah, Real Science Radio, and it was broadcast on KLTT out in Denver, 50,000 watts. And they put it up on YouTube, and YouTube censored it. They censored it, that's right. Hey, come on in, Danielle. Yeah, they censored the video, and something you need to know about me is I hate censorship. I despise censorship. And, it's really a double wrong. It violates the person's right to say it, and it also violates the person's right to hear it. And if we're going to make informed decisions, we need all the information. And when YouTube took it down, I got emailed. Fred emailed me and said, hey, they censored our video. And I emailed him back and said, hey, welcome to the party. More people will probably see it now than if it wasn't censored, and that's exactly what happened. It's like, well, how can you watch it if YouTube censored it? Well, you go into Rumble. They started a Rumble channel just because of the censorship, and they put me up there, and the topic was, should I vaccinate my baby? And apparently YouTube did not want you to know what vaccine experts were saying. Okay, and so then I'm coming through St. Cloud, and on my way back from that talk, and from that trip, and I go by St. Cloud State, and we're going to be promoting the very first online Hydroplate Conference. So excited because we had 3 PhDs that were going to talk, and so I put this poster up at St. Cloud State, and somebody stole it. And so we put it up again, and somebody stole it. And I've been asking students all week, is this offensive? Answers to scientific problems? And there's a whole list of things that scientists can't answer from the blind chance and random collisions of atoms perspective, like the origin of Grand Canyon. That's the talk I did out in Denver. And you go into their website, they got 4 theories, none of them work, but this one works, the hydroplate does. And we go through a lot of those, we'll hit a lot of those on our talk. So anyhow, we did the online Hydroplate Conference, and it was phenomenal. And I went into the science departments before it happened and invited them to watch it. And now the talks are online. This is on Rumble. You can go into Hydroplate Conference and you can see all the talks. You can go into hydroplate.org and you can see the schedule and the qualifications. And if you look at this, there's PhD after PhD after PhD who are talking about this hydroplate. And the middle one there, he's a professor of aeronautics at the U.S. Air Force Academy. So we've got some really sharp people on our side. And so we did the conference. They found the poster thief, but they won't tell us if it was a student, faculty, or staff. And again, censorship irritates me. And I called up Lynn, and I was scheduled to speak this month. And I asked him, well, what do you want me to speak on? And he said, the hydroplate. And I thought, perfect. We'll take that poster that was stolen, and we'll just look down on the bottom. We'll change it from online to in person. And so we put it back up at St. Cloud State. And then we had a table. Hey, see what a poster thief wanted to censor. And so then the students all wanted to talk to me. It's like, what did they try to censor? And because up until then, it was kind of slow at St. Cloud State. It was gone quite a bit, but I really didn't have very good conversations. But when I put that in, it's like, oh yeah, they wanted to see. And so then we got 50 flyers. And these are 50 flyers like this. We put them all over campus at St. Cloud State. Every bulletin board we could, we put them on there. It's in the dorms, and it's during homecoming week. And again, I don't like censorship. So when they censor it, it's like, I may do things I don't normally do. So then we got that, and then we got 10 more printed so I could poster them over at the vocational school. And the same thing, see what a poster thief wants to censor. And that opens some really good conversations. I go back to St. Cloud State, and it say, will SCSU allow the hydroplate theory to be discussed or return to the Dark Ages? See, the Dark Ages is when they tell you what to think. And that's what's happening in our science classes. They're telling kids what to think, and it's all based on blind chance random collisions of atoms. And so there was another time there, let's see, I'll show you this other one. It says, will SCSU lead us out of the dark ages of the blind chance random collisions of atoms dogma? And the president of the college went walking by there. And one of the administrators came walking by, and I really like the administrator. We've had some really good conversations. And he says, yeah, St. Cloud State's leading us out of the dark ages. We're teaching them how to think. And I said, you're not teaching them how to think in the science class. You're forcing them to think a certain way. And I say, will you allow the hydroplate in the class? And there's going to be a truth. Truth will prevail. The truth of the hydroplate, if that's allowed in class, it'll answer all these unanswered questions, and you can throw the big bang on the scrap heap of history where it belongs. And if it's not allowed in class, the truth that will prevail is you're not getting educated, you're getting indoctrinated. And so I've been talking to a lot of students like that, and some of them, a lot of them, agree with me. And I was there again today. Answers tonight at 7 o'clock. And I've been on a lot of campuses. I've started a lot of creation clubs. And I've been in Florida and Ohio, and no, not Ohio, but Pennsylvania, Illinois, Wisconsin, Minnesota on these campuses. And one of the state colleges invited me to speak. They had a club that invited me to speak, and they marketed it really well, 120-some students. They gave away Chick-fil-A at the end. And you can see this talk on my YouTube channel called Think Outside the Boxes. But if there's anybody watching online, and you want me to come and speak at your college, you can email me at gracecampus@proton.me. That's gracecampus@proton.me. And I was at one of these colleges, and a student invited me to class. He said, be at such and such a place and such a time. I thought I was going to a club. But when I got there, there was a professor there. And he said, I heard you might be coming. Come on in. When the students get here, we'll let you talk. And they gave me 15 minutes to talk. I was done in 10. I said, are there any questions? And we did 10 minutes of Q&A. And the professor asked me, well, what would you do if you were in charge of the science department? I said, I would let every theory on the table. Let's critique them, and let's focus on the one that makes accurate predictions. And then I also said, we do science also, observable, testable, repeatable science. And not belief systems about the past. Belief systems about the past, the Big Bang, evolution, those are belief systems. That's not science. We don't need to touch it. I mean, if you're a heart surgeon, you need to know your anatomy. You don't need to know how it got there, because it's just a belief system. So that's the backdrop to where we're coming from. Okay, what I'd like to do is change your perspective of the Earth and the solar system, because perspectives matter. They really, really matter. And when I was inviting people, and I talked to the students too, we got that online conference. If you can only listen to one talk, listen to the Comet talk. You can go into hydroplate.org, and it'll be the origin of comets and asteroids. Or you can go into Rumble on the Hydroplate Conference, and you can go watch Comets, Asteroids, and NASA Blunders, because they really messed up. Really messed up. 6 years ago, Kevin Lee, because Kevin Lee's given the talk, and if you can only listen to it, can't listen to the whole thing, listen to it at 22:15 and 31:45, because Kevin Lee's going to talk about being face-to-face with a NASA scientist in charge of the Stardust mission 20 years ago. They were going to get the material from the comet back to Earth. And Kevin said, predicted, you're going to find stuff from the Earth in that comet. And the Brownlee says, no, we're going to find stuff from the Oort cloud in that comet. And he was shocked and dismayed to find stuff from Earth. So chalk one up for the hydroplate. And they want to redirect an asteroid. So Kevin emails him 6 years ago, and he kind of reviewed, like, hey, I was right about the comet. I might be right about this. And he says, it might work if that asteroid's a solid rock. But if it's just a loosely held together pile of rocks, it's going to fail. And guess what happened? August 9th, 2023, NASA had a press release, or a headline from Science Times. NASA accidentally causes Dimorphos boulder swarm as deadly as Hiroshima during DART mission. So that asteroid was not a solid rock. That asteroid was a flying rock pile, which was what the hydroplate predicted. And now we got Hiroshima-sized boulders, 37 of them coming towards Earth, because NASA made a colossal blunder based on a bad perspective of the past. And my motivation, they were planning the next year's Hydroplate Conference, and she got an email. What's your your two top priorities for next year? Is it to get the date set? And I said, no, my biggest priority is to get this theory into the mainstream before NASA makes another catastrophic blunder. And so that's what I'm trying to do. And we got Facebook, so I'm posting this on their NASA Twitter account and stuff like that. But going to the article, the large space rocks have the same speed as the targeted asteroid, so they are as dangerous. And it says there was unforeseen implications. That's not true. Kevin Lee told them this could happen, so it was foreseen. They just chose to ignore it. And let's take a look at what they ignored, or what's happening now. There's about 37 rocks coming at us, 22 feet wide. And if they're 15 feet wide, they're going to be as powerful as an atomic bomb that got Hiroshima. So that's what NASA did. But if you go into their website, they're bending over backwards, patting themselves on the back, seeing how great a job they've done. So what we need to do is get this out there. Okay, so now what is the hydroplate theory? I could have gone on for 20 minutes. Question. These questions that scientists can't answer, but for sake of time, I just skipped all that. And this is, we had questions about mountains, plateaus, trenches, submarine canyons. It goes on and on and on and on. Asteroids, comets, all these seemingly unrelated topics. And if there was a theory that could tie all these topics together, would that be worthy of study? Who thinks that would be worthy of study? 1, 2, 3, 4. Okay, most people. Good. Some people don't think it's worthy of study. Well, there's a lot of them at St. Cloud State. I was shocked. We got answers to scientific problems. I was stunned how many students did not want to know what they were. It was really stunning to me. But the theory that ties it all together is in the beginning. It's a 300-page book, and when it was new, you could buy it for $30 at Real Science Radio. And now this is the 8th edition. It's out of print, and now it's $280 on Amazon.
Wow.
Yeah, $280. That's the sign of a good book.
Yeah.
That's the sign of a real good book. I got some science textbooks from the college. I spent $215 for 2 of them. I figured I want to see what the kids are learning, and then when I went to sell them back at the end of the quarter or semester, they'd give me $10 for one and nothing for the other. Yeah, it's a scam right there. But this is the sign of a good book, and at the end I'll show you how to get an electronic version of the 9th edition for free. So we need to get this information out there. And it is a powerful theory. I got this email from somebody about they've been praying for a guy, and I just happened to buy a product for him, and I got this email and says, your conversation with him has opened his mind. I believe he's been watching your videos a bit because he shared one with me. And I thought, well, that's interesting. Which one did he share? Because I got a ton of videos, dinosaurs, evolution versus science, who's your daddy? And she emailed me back and said, it was the hydroplate. I squeezed this talk into 20 minutes for the Rotary Club. I had 20 minutes to talk, and it was during COVID, so the doors are open. There's a lot of background noise. I tried to get rid of it and just destroyed the audio. But the information content overcame the bad audio because that's the one he shared with her. So the hydroplate is very powerful. Very, very powerful. One guy even took the CD of it up into space, and that's hanging in Walt Brown's office right now. So Walt Brown, where did this theory come from? I think Walt Brown's the Isaac Newton of our day. Whenever they discover something new, it's like, well, yeah, that validates what Walt said. And his background was he went to West Point. He was an Army Ranger, paratrooper, got his PhD from MIT in mechanical engineering. He's just sharp as can be. He ran the Benet Military Lab where there's dozens of PhDs and hundreds of scientists. And he also was the chief of the U.S. Space and Technology Studies at the Air War College. So he's super sharp, super sharp. And he's a mechanical engineer, so he's looking at the Earth and, what's the force, what's the mechanism, what's the energy? And he's spot on almost everything. There's Walt Brown on the left and Bob Enyart on the right. And Bob Enyart is how I heard about Walt Brown. They've got this hydroplate theory on CD. You can get that for $20 at rsr.org. Christmas is coming. You might as well support the stores that are doing godly work, and they've got hydroplate theories for Brian Nichols got one, and also Bob Enyart, they've got one. And so I encourage people to vote with their money. Don't give it to godless corporations. These guys are doing good work, really good work. All right, so let's get to this other perspective. Okay, now the hydroplate theory, most theories that look at what the effect is, we know what the effect is and we try and figure out what caused it, but we never really know the cause. This is different. He sets up the cause with only one assumption. Just one assumption lets the laws of physics go at it, and then it fits the world perfectly. See, the other theories, they got the known and they got the unknown. They go from unknown to known, try and figure that out. This is different. You go from the known to the known, and he's just hitting the ball out of the park when it comes to predictions. And I gave that book to, I was at St. Cloud State in the Earth Science Department. And I met one of the professors, and I had the book, and I said, "You don't have a theory for Grand Canyon." And my brother-in-law, he took a geology class there one time. They spent a week on Grand Canyon. None of the theories worked. And on Friday, the professor says, "You know, there's one theory we haven't talked about. Anybody know what it is?" Kid raised his hand and said, "Noah's flood." And the professor said, "Yeah, you're right, but we can't talk about it." And so that's what's happening over there. And so she knew that they didn't have a theory for Grand Canyon. And I held up the book and I said, "Here's a theory that works. Would you like to look at it?" And to her credit, she said, "Yeah." And so she had it for 6 months, and we got together and talked for an hour and a half. And she said, "If the assumption is true, the science works. I just don't believe the assumption is true." So this, again, is based on just one theory, or one assumption. What's the assumption? It's half the ocean was inside the earth at one time, 60 miles deep, under granite. So just think of the earth as a big apple. The skin is 60 miles thick, made of granite, and then there's a layer of water underneath that, about a mile thick, and then underneath that is basalt. And the granite and the basalt are touching at various places. That's the theory. How it got there is not part of the theory. But once you have that and let the laws of physics go at it, you're going to see how it matches everything right now. So that's the one assumption. Okay, now how do you get the laws of physics to start working? You got the moon. The moon tugs on the earth, causes high tide and low tide twice a day. It's going to tug on the crust also. And back then, the crust wasn't broken into plates. It was just the crust. So it stretched and compressed, stretched and compressed, stretched and compressed. If I had a wire going back and forth, it would get hot. So that stretching and compressing causes heat. Heat goes into the water. Water gets hotter and hotter and hotter. It wants to boil, but there's no room to expand to boil. So at 705 degrees and 3,200 pounds per square inch, it becomes supercritical. They've known about it for 100 years, but a lot of professors have never heard of it. Supercritical water, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. And so now it's starting to dissolve the granite above and the basalt below. And it's starting to mix together these minerals and make calcium carbonate and silicon dioxide and sodium chloride, which are fancy words for limestone and chalk and quartz and salt. And so it's starting to put together all like limestone. Where did all the limestone come from? When limestone is formed, it gives off some carbon dioxide. But there's 60,000 times more limestone than there is carbon dioxide in the atmosphere. And Walt Brown, he asked Bob Dietz, the guy who coined the term, I think it was seafloor spreading. He asked him, "Where did all the limestone come from?" And Bob says, "Beats the blank out of me. They can't explain it." But right here, that carbon dioxide is just getting recycled over and over and over again, making that limestone. And so you got this big layer of salts and silicates and cementing agents, all that stuff in that subterranean water chamber. It keeps getting hotter and hotter. The crust gets weaker and weaker, and eventually there's just too much pressure. Walt Brown says there was 372,000 psi in that water. And when the Earth's crust cracked, it just erupted out of there with tremendous force. And then it ripped the Earth in two directions. And it went around the Earth like a seam on the baseball and came back together again. And that's how you could have it rain for 40 days and 40 nights. It was tremendously powerful. And people ask me, "Well, if that happened, Brian, wouldn't that leave a mark on the Earth?" It's like, yeah, and it did. It's the mid-oceanic ridge. There's a mountain range, 46,000 miles long, that goes around all the oceans and comes back together on itself. And you see the circle on the right, Walt Brown thinks that's where it ended. It came together and then it just shot out from there. So you run the movie backwards, he thinks it started up by Alaska. And it cracked there and then it went in two directions and came together. And it just went up with tremendous force. And that's where you get all the sedimentary rock. You ever wonder where all this sediment came from, the sedimentary rocks? Well, it's getting eroded from the basalt and the granite. And sedimentary rock, if it doesn't have carbon in it, like limestone, it's going to be 65 parts granite and 35 parts basalt. And that's because I think it's getting eroded, the granite's getting eroded on the bottom and on the sides, whereas the basalt is just getting eroded on the bottom there. So you're going to get that ratio there. And so that's where all the sediment comes up. And on Earth, you can only get cliffs that are 5 miles high, because otherwise it's going to crush the overgrowth. And now it's going to crush the rock below. And these are 60-mile cliffs. So you got those cliffs crumbling into that supersonic water, shooting out like crazy. And that's, again, where you get sedimentary rock. And this sediment gets laid down all over the earth. And this is continent-wide layers of sediment. You can't lay down that with millions of floods. This was all laid down at one time. And this is from Is Genesis History? It's a really good movie. I donated it to a state college that I spoke at. And the librarian says that video is never on the shelf. It's always being checked out. People want to see it. There's a couple of things I disagree with on the video, but it's really, really good. Highly recommended. And not only does that Zuni mega sequence cover all of North America, it goes all over the world. Tim Clary, he spoke at Twin Cities Creation Science Association, remember, next Tuesday, who wants a ride? He said he finds that same sequence all over the world, so it's a worldwide layer of sedimentary rock. And if Randy Galuza was in college, he'd be asking his professor, excuse me, professor, what process today is laying down layers of rock, layers of sediment worldwide? It's not happening today. That happened during the flood. So you get all this stuff crumbling down, and now the sides of the cliff, you got two 60-mile cliffs, and they're eroding, so they're getting farther and farther and farther apart. Eventually, there's nothing pushing down on the mantle, and the mantle bulges. And so now the continent starts sliding. It's like if you had a railroad track, you lift up one end, the train's going to start sliding. And that's what happened with the continents. Now you got North America and South America sliding to the west. You got Europe and Asia sliding to the east. And they're going to keep on going until they meet resistance. And then they're going to buckle up and form the mountains. And if you notice, that's why the mountain ranges are pretty parallel to the Mid-Atlantic Ridge. And Walt Brown doesn't think there was an Atlantic Ocean before the flood. And they do that Pangea thing. They try to put the continents together, but they don't really fit. But if you line up the continents parallel to that ridge and allow a few hundred miles for erosion and some sliding, it fits really well. And if you notice that the Rockies are twice as wide as the Andes, and I think that's because the North America slid over the mid-oceanic ridge right there. That's my 2 cents to the theory. I don't know if it's right or not. But, you know, when these continents are sliding on supercritical water is 38 times more slippery than water, more viscosity. And it's going to keep going until it meets resistance. When it runs out of resistance, there's a lot of momentum, a lot of mass that's going in one certain direction, and there's going to be a lot of heat and a lot of friction. It's going to melt a lot of lava. And that's how we're going to get the coal and the oil deposits. That's also how we're going to get the metamorphic rocks of marble and diamond, which marble is limestone and heat and pressure, and diamonds are coal and heat and pressure. Where did all that come from? And yet we're going to find all carbon-14 in all that stuff, which shows that they're less than 100,000 years old. It cannot be, because they say, well, it's contaminated. Well, it doesn't matter where you take the coal from, which seam you take it from. It's got pretty much the same amount of carbon. If it was contaminated, it should all be random. And how do you contaminate diamonds? You know, that's the hardest substance on Earth, naturally. You got these folded mountains near British Columbia. So that had to be soft sediment when it got folded like an accordion. And it had to be soft because they're not broken. Rock doesn't bend real well. And if you don't believe me, just bend your finest piece of china at home. See what happens. So these were soft mud, got compressed like an accordion, and then over time that sediment was mixed with a cementing agent, turned into rock. And this is Gunnison Canyon. For scale, those are 15-foot trees on top. So there's a huge force that compressed that granite. That's not a tension crack. Tension cracks are straight. Rocks you can pull apart pretty easily. And when the pressure is released, it just cracks. But this is a compression one, where what force would be able to squeeze that much granite? I would say it's a continent getting stopped. And there's all that momentum coming to it. And that's the same pattern you see at the bottom of Grand Canyon. The basement rock at Grand Canyon has the same sort of design, the same sort of compression marks. And when it's compressing, it's going to bend up a little bit. So now the sediment that's on top of it, it's going to be slanted. But there's still sediment that's still moving to the west. And that's going to shear off those slanted ones. And that's how you're going to get slanted layers underneath flat layers in the Grand Canyon. How do you explain that with the Big Bang? It's real tough. And also there's this quartzite rock about as big as a table that got lifted up into sedimentary rock. That quartzite broke off from where it was and got moved along in the mud, got raised up there a little bit, came to rest, and then now it's in a sedimentary rock. Okay, so it started down at the bottom right and it ended up in the middle there. And I've been all over that Grand Canyon website, and they don't put this rock in there, because you can't explain that with millions of years. There's no way, and that's 5 to 10 tons. And this is by Isis Temple. And those are the coordinates of it. I think those are Walt Brown's grandsons right there. Just a huge rock got lifted up, and they keep that off the website.
That's cool.
Yeah. And then also, so then the Mid-Atlantic Ridge. Notice those are tension cracks, and that bulged right there. So the Mid-Atlantic Ridge rises up. And that's how you get a mountain range formed by stretching it in two directions. Notice, see the vertical and the horizontal lines that are straight? Those are tension cracks. It's getting stretched. It's breaking apart like that. That's how you make that 46,000-mile ridge. And if that's rising up, hey, something's got to go in. What's going to go in? It's the Pacific Ocean. Pacific Ocean, that's why you got that ring of fire there. That's why the deepest parts in the ocean, the Mariana Trench, almost 7 miles deep, is in the Pacific Ocean. It got sucked in. Okay, it's deeper than Mount Everest is high. And that's why most of the trenches are in the Pacific. That's why most of the volcanoes are in the Pacific. That's why it's so much different than the other oceans. And they got 40,000 of those volcanoes there. So it got sucked in. It even sucked in a continent, Zealandia, the 8th continent. Live Science says it. It says they found evidence of land-based fossils underneath the ocean. And Walt Brown had predicted that you're going to find granite in the Pacific. And that's what they found. And it's about the size of India. Okay, so now the worldwide flood that was covering the world, all that water, the Pacific Ocean sinks in, so now their water can gush off the continents to fill in the oceans. And that's what's going to cause these submarine canyons. These are canyons that are longer than Grand Canyon, and yet you can't cut a canyon underneath that deep in the ocean. So what happened there? And this is the Ganges, the Congo, the Hudson, the Amazon. They've all got these huge canyons underneath the water. Well, Walt Brown says the continents were higher back then, and the water gushed off to fill up the Pacific Ocean, cut those canyons, and then the continents have sunk in and the oceans have risen up and buried the canyons in water. And also during the Ice Age, the ocean level was 125 meters lower than it is today. And how does a canyon form under 2 kilometers of ice in Greenland? Yeah, it's a canyon cut by a river and it's full of ice. How does that happen? Same thing in Antarctica. They got lakes under 2 miles of ice. And that's really hard because the average summer temp for Lake Vostok is like 22 below zero. But yet there's liquid water under there. How does that happen? Well, and speaking of Antarctica, they found 91 new volcanoes beneath Antarctica's ice. So if people are freaking out about the ice caps melting, maybe it's one of those volcanoes. There's a lot of things we need to look at. And I encourage people, inconvenient facts should be required reading for everybody. I'm a big proponent of getting both sides of the issue. You know that saying, beware of one hand clapping? There's 2 sides to every issue. Beware of one hand clapping means you're only being presented one side over and over again. Chances are the other side is being censored by those in authority because they don't like it. But Inconvenient Facts, the gist of that book is carbon dioxide is plant food. If we had more carbon dioxide, we'd have more food and less droughts. And then you go into CO2science.org and you can see how that scientifically validates that. But what happened with those? The water gushed off, it filled up those lakes, and then the Ice Age filled them up. So how did the Ice Age begin? They got 40 theories, which means none of them work. And to get an Ice Age, you need it to snow more than it melts year after year after year. And so you need warmer oceans to get the precipitation, but yet you need cooler continents so it doesn't melt. How are you going to get that dynamic? Well, the oceans are warmer with all those volcanoes in the Pacific. The oceans are warmer. But then you're going to get all that precipitation coming down on the continents. But why won't it melt in the summer? Well, Walt Brown, again, he says the continents were higher, therefore cooler. You go up 1,000 feet, that's 3 degrees cooler. And also, with all that volcanic activity, there's a lot more aerosol in the atmosphere, so it's going to reflect the sun's heat. So 400 or 500 years of it snowing more than it melts, you're going to get the Ice Age everywhere, down to Minnesota, except in parts of Alaska. I couldn't believe it when I saw that. Parts of Alaska and Siberia, where there's permafrost, had no glacier in the Ice Age? Mr. Evolutionist, explain that one to me. They got permafrost today. My my son went to Pensacola Christian College, and his roommate was from Inuvik, Northwest Territory, above the Arctic Circle. And I said, hey, Norman, how do you do your pipes? We do our pipes in the ground so they don't freeze. Your ground is frozen. What do you do? And he says, we have utilidors. You either drive over them or drive under them, and it's heated pipes. But that's where they live, and it's dark a lot, or light a lot. But yeah, how do you get that? Well, why wasn't that ice right there? Well, it came down as rain. It had the moderating effect. It came down as rain, so it didn't snow. So it just rained instead of snow. That's the hydroplate interpretation of that. And just to prove that sediment from or aerosols from a volcano can mess up your weather, in 1850 in Mount Tambora, they had a year without summer. That was Tambora was in was it Indonesia? Erupted. And there was so much stuff in the atmosphere. New England they had the year without summer. They had snowstorms in June and ice formed in July. And I love getting these NASA pictures of volcanoes erupting. Just think if you had hundreds or thousands of volcanoes erupting. And so that's going to cause the ice age. Well, how come it stopped? Because once you get an ice age going, it's going to reflect more and more of the heat from the sun, reflecting off the snow. So it shouldn't stop ever. But it did. Why did it stop? Well, over those 400 or 500 years, the oceans cooled off. So there's less precip. And also the atmosphere cleared out. So there's more heat getting to the surface of the earth. So you got 400 or 500 years to make the ice age, 100 or 200 years to melt it. And we're still recovering it to a certain extent right now. And that's what we need to keep in perspective. We need a proper perspective of the past. And then they found this frozen mammoths all over the place up there. I think they had 500,000 tons of ivory they've taken out of there. But they found one of the mammoths standing up, frozen, with identifiable food in its stomach. So it froze so fast the stomach didn't rot what was in it. Any hunters out there? What do you do when you shoot the deer? First thing, you got it. Otherwise the heat's going to destroy the meat. This was flash frozen. How are you going to flash freeze a mammoth? And keep in mind, mammoths are not Arctic animals. They call them woolly mammoths, but that's a misnomer. They're hairy mammoths. They eat too much, they drink too much. There's no way they could live up in the tundra. They're a temperate animal. So the question is, how did it get so cold so fast in late summer? They could tell it was late summer by the food that was in its stomach. That brings us to the cold hail. Some of that stuff that was shooting out of the great deep was going up with such force that it escaped our atmosphere, went up into the cold heat sink of outer space, got super cold, gravity pulled it down. So you got this mud and carbon dioxide turning into dry ice up there, and ice and water comes slamming down on the mammoths and flash freezes them to the ground. And so that's how that's how you get them frozen standing up. Okay? And so, okay, that's how you froze them. Well, how come they didn't thaw out if they're temperate animals? That brings us to the big roll. Okay, now the North American and Northern Hemisphere and Southern Hemisphere, they pretty much balance out as far as mountains go, except for the Himalayas. Let's let that orange dot be the Himalayas. That's a big mass on the Northern Hemisphere, and it's going to spin. And it's got a big mass, so laws of angular momentum, it's going to try to get to the side. And since the something on top is going to the side, that means something on the side is going to the top. Yeah, you notice how far it's gone? And I think the Himalayas moved about 3,000 miles, is my guess. You got Mammothville here, where they're all fat and sassy, lots of water, lots of food. And then the Himalayas get formed, and so then it turns Mammothville up to Mammoth Chill, where they never thawed out. And it's the same thing with Axel Island and Elmsmer Island up in north of the Arctic Circle. They got evidence of snakes and tortoises and alligators and badgers and shrews and redwoods. How in the world are you going to get redwoods up there where it's dark 4 months of the year? Well, it's just how the earth rolled. It took something from the side and brought it to the top. And it also took tropical palm trees and brought them down to Antarctica. This says South Pole is mostly covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived on the land. Palm trees. And maybe crocodiles and dinosaurs if it's warmer, maybe. But palm trees where it's dark 4 months of the year? So it brings us to the big roll. So Antarctica, part of Antarctica at one time was tropical. And then it got moved to the bottom. And I think it was 3,000 miles because that's how long the 90 East Ridge is. See, there's a bulge at the equator. And when it rolled through the bulge, it cracked the Earth. And there's a crack that points directly at the Himalayas called the 90 East Ridge. Do you see that over there? Straight, right towards the Himalayas. So I think that's 3,000 miles long. So I figured the Himalayas, they were 3,000 miles farther north at one time. That's what my guess is. Okay, and so now you got these mountain ranges that are parallel to the Mid-Atlantic Ridge. And right next to the mountain ranges, you got plateaus. And that's another mystery that the Big Bangers can't answer. What mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? And it's a double-sided mystery, double-ended mystery, for the Colorado Plateau seems to have grown downward at the same time its emerged part arose upward. Okay, so now you got these mountains. It's a big mass on a small base, so it's going to sink in. Well, again, if something's sinking in, something's going to rise up. Sinking in, it's going to squeeze all that lava to the sides, and then what's weak on the side is going to block fault up. So it's not a mystery anymore. What's the mechanism? It's hydraulics. What's the force? It's gravity. Mountains sink in, plateaus rise up. And when you look up plateau in the dictionary, it'll say at least one side is steep. And I would suggest maybe, and the other side is a mountain, is what I would suggest. And so with the water squeezing out the side, forcing those blocks up, there's going to be cracks, and lava could get to the top of those cracks and get on top of the sediment. And when a big whole bunch of water, which comes through it's called the Great Denudation, to clear off Grand Canyon before you cut Grand Canyon. Two lakes are breaching, and we can talk about that, but the water's not going to wash away the lava. It's going to wash away the softer sediment. And that's how you're going to get Red Butte, which is 1,000 feet of sediment with lava on top of it. And Red Butte is really close to the Grand Canyon. So that whole area there had 1,000 feet of sediment of it on top of it. And that brings us to Grand Canyon Answers. I love this talk. And during the online conference, we were going to play a video, and it didn't work. The sound didn't work. So I had to do this real quick. We did an impromptu Grand Canyon Answers talk. So you can see that on the hydroplate.org. You can see this. And so I've been posting it at Grand Canyon's website on Twitter and Facebook and stuff. It's like, you guys don't have a theory that works. Would you want to put this one up there? And so anyhow, what's the key to Grand Canyon? There was two huge lakes there, Grand Lake and Hopi Lake, enough water for 3 Great Lakes. And there's the big funnel right there. And keep in mind that the depth of these lakes, if you were in Grand Junction, Colorado, you'd have 1,100 feet above you. It'd be 1,100 feet deep there. If you were at Page, Arizona, you'd have 1,400 feet deep right there. And Farmington, New Mexico, 350. This is a deep, deep lake, big lake. It's like nearly 3,000 cubic miles of water, a mile in the air. So just think of that potential energy once that starts flowing. And then Hopi Lake, you'd have Tuba City and Winslow under 1,000 feet. And then Holbrook underneath 900 feet. And so what happens here? You look at that funnel right there by the edge of that lake. That's what happened. The lake breached, and it started going over the top, and I didn't put it in this talk, but there's potholes right next to a 2,000-foot cliff. You get potholes by a rock being in a vortex, digging in the mud, and it makes a pothole. And it's on a 2,000-foot cliff 4 miles from the river. Mr. Big Banger, how do you explain that one? And I noticed that's not on their website either. But for sake of time, I took it out. You can see more of that stuff on the Grand Canyon Answers talk. So it's going over the lake. It's cutting down through all this soft sediment, and then it hits the Kaibab limestone, which is hard. And then it spreads out, making that funnel. And so now you got 2,000 feet removed from that Kaibab limestone. And so that limestone, it bulges. And then when it bulges, it cracks. So now the river flows through the crack, and it undercuts Hopi Lake. So now you got 2 lakes draining like crazy, and this one's is 250 feet higher than Grand Lake. So there's tremendous kinetic energy just eroding just sweeping the Kaibab limestone clean, removing 2,000 feet of sediment. And 2,000 feet of sediment weighs quite a bit. So now there's nothing pushing down on that area. So now the Kaibab Plateau rises. I think it's more of an upward because it's actually gradual on each side until something else happens. But the Kaibab Plateau rises up, and when it bulges, it cracks. That's the key to Grand Canyon, bulging and cracking. You do it 3 times. And so now the river runs through the plateau instead of around the plateau. And then it goes through there, and it starts eroding things like crazy. And just think of all that water gushing through. And it's just it's cutting down that sediment, and then it gets to the basement rock of the Grand Canyon. It should have spread out because it's softer sediment there instead of going deep into the granite. But again, it bulged. The basement rock, it got rid of all that sediment, and then that bulged. The basement rock cracked. That's what the inner gorge is. It's a crack in the basement rock, and the water went through that. So bulging and cracking 3 different times, that explains Grand Canyon. And I hope they put it on their website. That's my goal. Get it on the website so you had a theory that works. Okay, now we're going to explain what caused the inland seas. That's like the, Walt Brown says that's the Gulf of Mexico, the Mediterranean, the Black Sea, the Caspian Sea. These are seas that have a lot of salt at the bottom. He thinks that's the bottom of the subterranean water chamber. And we're going to answer that question along with, how do you fuse past iron? That's one of the 11 unanswered questions in physics according to Discover magazine. How do you fuse past iron? And it comes down to granite. Granite's a very unique rock. It's never been molten. It's made of feldspar, quartz, mica, and hornblende, and they all have different specific densities. So if they ever were molten, which is what the Big Bang says, Earth was a molten blob at one time, those things would have settled out into their specific densities, but they're not. They're all mixed together. Therefore, granite was never molten. And quartz is very, very, and it's at least 27%. Some granite has more, some has less. But quartz is piezoelectric. Piezo meaning pressure, electric meaning spark. When you stretch it or compress it, it's going to make a spark. And just think if you had 60 miles of this stuff, stretching and compressing. They call this fluttering, because that's what's going to happen when the water's shooting out. It's going to release the pressure. The continents are going to slam down until the water pressure gets built up again, and it's going to keep slamming down. And so the plates are going to keep getting tension and compression back and forth. It's going to flutter, kind of like a flag. And there's going to be a lot of stretching and compressing, a lot of electrical energy in there. And there was a guy who says, that doesn't happen. There's no lightning in granite when there's earthquakes. Well, that's not what the Smithsonian says. Why do lights sometimes appear during an earthquake? Or Live Science, mysterious flashing earthquake lights. Or Nova, what causes eerie earthquake lights? Or Nature, earthquake lights. Yeah, there's lights. I think that's electrical charges from that quartz. Bizarre earthquake lights. And what's going to happen when you get that lightning in the granite, if you will, plasma? This is, how do you fuse past iron? And this is out of my wheelhouse. I'm taking this from Brian Nickel. He does a really good job of explaining it. Supernova capabilities is you can get up to iron, but then how do you fuse past iron? That's a real mystery. But you can Z-pinch and make all the elements and more. What's Z-pinch? It's when you have nuclear fusion. You take really pure electrode of copper and you hit it with a hot dot going really hot, really fast. A stream of electrons, I think, is what it is. And that's that? Okay, stream of electrons hitting the copper, and that's going to produce 94 natural elements plus a bunch of super heavy elements. See, Walt Brown doesn't think there was radioactivity in the earth before the flood, because would it be very good to have uranium out there that can cause birth defects? And God said everything was very good. So he thinks that the radioactivity was formed during the flood with all that fluttering going on. And you get those super heavy elements which are unstable. So they're going to decompose or degrade until the valley of stability, where there is more stability. And you see that in lightning, you have plasma. You know, that's when the electrons are sheared from the protons or nucleus, I believe, and it goes to the ground, and there's an expanse in the air, and then it slams back together, and you got the thunderclasp. Well, the granites can't really expand that much, but it does have a rebounding effect, and it's going to slam a bunch of molecules together, and boom, and now you got those 94 elements and a bunch of super elements there, and then they're going to decompose. And so that's how you get the inland seas, because with that going on, there's going to be some real hot spots on the crust, and it's going to get really weak, and there's going to be a lot of pressure, and it can just explode. So that's how you can get those inland seas. Boom. And there they are. And then also, that's how you're going to get all these free neutrons, which is going to explain why comets have twice as much deuterium than the ocean. And deuterium, that's heavy hydrogen. Hydrogen is a proton and an electron. Deuterium is a proton, an electron, and a neutron. Where'd all these neutrons come from? Well, I think it came from that fluttering, that plasma stuff. And the Big Bang Theory says that the oceans came from comets. Well, if that was the case, they'd have the same amount of deuterium in there, but they don't. And so it's diluted, I think, by 50%, or it's twice as much deuterium up in the comets. And I think it's because the ocean diluted the rest of the stuff that came up. That's my 2 cents for it. 2 cents worth. And now some of the stuff, it got shot out with such tremendous force. Not only did it break through our atmosphere, it broke out of our gravitational pull. And what's going out there? You got rocks, you got mud, you got dry ice, you got water, all that stuff. So you got stuff like described as dirty snowballs going through our solar system. What's been described as dirty snowballs? Anybody? Anybody? What? What's that? Comets. Comets. There we go. That's why he could predict they'd find stuff from the comets stuff from Earth in the comets, and they find water, silicates, salts, crystalline silicates, limestone and clay, which need water, cubonite, olivine, nickel, organics, amino acids, bacteria, cellulose, and cubonite. I had a slide in here before that basically that has to be in scalding hot water. I have a quote from Walt Brown, and you can't get scalding hot water up in a comet. You can't get water because it's going to instantly flash into steam. There's no pressure to make it stay water. And so you can't get cubonite up in space. They find all this stuff that shouldn't be there, but it is. And it's all from the Earth. And that's why Kevin Lee could be so confident in talking to Don Brownlee. This is what you're going to find, because this is the proper perspective. They also find rounded boulders in Comet 67P. How in the world do you get rounded boulders in space? Because if things collide, you're going to have sharp edges. The only way you get a rounded boulder is if it's going through a fast flow of water before it gets propelled up into space. And that's what the hydroplate theory explains that. And why do asteroids have moons? It's really hard to get a moon, because if two objects are coming together, they're going to slam into each other, get attracted more and more, break apart. By the way, that's how you can't get planets. They call it the aggregation problem. The things break apart. They don't stick together. Or they're going to slingshot one around the other. It's really hard to get a moon. And Bob Enyart predicted we're going to find more moons than we expect. And then there was Florence that had 2 moons. Not just one, but it had 2. Yeah, how are you going to do that? And how do you get these peanut-shaped asteroids? And this is their website. This is from Aviation Week and Space Technology. It says, it's a major mystery how 2 objects, each the size of skyscrapers, could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where gravitational forces would normally involve collisions at 4,500 miles an hour. They can't handle it. How does that happen? Well, this theory can explain it. See, their theory says, stuff comes together and it's going to break apart. It's like pool. Those balls don't stick together. The only way you're going to get it to come together in a peanut shape without blowing each other to parts or to even get a moon is they're all pretty much going in the same direction at the same time. And then the bigger rocks are going to collect the smaller rocks, and they're going to come together gently. And then you could get a moon. Okay, and then another question that's very hard on the evolutionists is, why do 93% of the short period comets, those are ones that come back every 100 years or less, 93% of them go in the same direction, prograde, as the Earth going around the sun? And if they all came from the Oort cloud, it should be a 50-50 mix, but it's not. So just think of the Earth as a train going 100 miles an hour. And now let's say you shot something off at 50 miles an hour. Doesn't matter which way you shoot it. You could shoot it straight back, but it's still going to be going that same direction. So these short period comets, they were stuff that got shot out with not as much force. And so now they're all going the same direction for the most part. And then you got the mid ones. Those are 100 to 700 years. That's like if you shot it off at 150 miles an hour. So they got shot out with more force. So there you're going to have more going the other way. And now let's say you shoot it out at 500 miles an hour. Now it doesn't matter which way you shoot it. It's going in that direction. And that's how you get these trans-Neptune objects that are puzzling them like crazy. Why is Nike orbiting backwards? What's up with Nike? Objects' weird orbit puzzles scientists. Well, they're puzzled because all they can think about is blind chance random collisions of atoms. They can only think about the Big Bang. But if they think about the hydroplate, it's no problem. They got shot out with more force that way. And it goes on to say, beyond Neptune, a chunk of ice is orbiting the sun in the wrong direction. Well, it's only the wrong direction if you got the wrong perspective. And this is from a professor of the Harvard Smithsonian Center. He says, the orbit of Naiku is unusual in that it's nearly perpendicular to the plane of the solar system. More than that, it's orbiting in the opposite direction of most solar system bodies. Furthermore, there are a few bodies that share the same orbital plane, with some orbiting prograde, that's the same direction as the Earth, and some orbiting retrograde, that's the other way. That was unexpected. There's a lot of unexpected Big Bangers whenever they find something new. A lot. And Bob Enyart does a show on that, the list of shocked evolutionists. They're head banging, they're always shocked, and I'll go to St. Cloud State and I'll play that on my Bluetooth speaker. And one time a professor walked by and he listened to it for about 10 minutes. And so we're just doing what we can to give them an opportunity to think. And that's what kids ask me, hey, what you doing here? I'm just giving you an opportunity to think. You got to see both sides if you want to think. That's not happening in your science class. And almost all of them agree with me. And then some of this water got shot up and landed on Mars. And so it got onto Mars. A lot of it just flashed into vapor and went to the poles. But some of it sunk into the ground. How do canyons form on Mars from water erosion? Well, some of it sunk into the ground, so you got ice in the ground, and then if it gets hit by a comet or a meteor, that's going to cause it to melt. There's going to be heat there. It's going to melt, and then it's going to flow down the side, and then you get water erosion on Mars. Okay, that's quite a theory, you know. And what some people ask, well, if that really happened, wouldn't that leave a mark on the moon? It's like, oh yeah, it sure did. You look at the near side of the moon, and it's been pounded. You see that dark area? That's lava flows. It's been pounded like crazy. Marias or something. But on the far side of the moon, it's pretty clean. Doesn't have hardly any lava flows, which is really, really counterintuitive. Why it's so different. The high density is on the near side of the moon. So we only see one side of the moon. And really counterintuitive because the Earth shields the near side of the moon. Just the Earth itself. And then when you throw in the Earth's gravitational pull, it's really hard to get a direct hit on the moon. So how does the Big Banger explain that? And they also found the world's oldest rock, Earth's oldest rock. Anybody know where they found it? They found it 50 years ago. They just didn't tell us about it on the moon. Yeah, they found it 50 years ago. They just didn't release it till a year or two ago. Why was the Earth's oldest rock found on the moon? Yeah, this is from NASA. That's their press release. Earth's oldest rock found on the moon. And it goes on to say, they found evidence that the rock was launched from Earth by a large impacting asteroid or comet. That's when you ask, how do you know that? Can you verify that? Has that ever been observed? No, that's fiction. That's their idea. But it goes on to say that the rock crystallized about 20 kilometers beneath Earth's surface. So about 12 miles deep. And that's what the hydroplate would say. It got formed there and it got shot up there based on the hydroplate. So this theory explains a lot of unanswered questions, and I didn't even get to all of them, but you can see that on the Hydroplate Conference. And it makes accurate predictions. It predicted that there'd be pooled water under mountains, and it was right. Deep channels under Bosporus and Gibraltar, and it was confirmed. Salt on Mars, confirmed. Rocks are flying rock piles, confirmed, and tragically confirmed again because NASA just did not heed the warnings. And also rocks on asteroids and comets are rounded, confirmed. Water inside large asteroids, confirmed. Planet X will not be found by January 2021, confirmed. Carbon-14 in old bones, confirmed. And now they found blood cells and bone cells and nerves. Those dinosaurs did not live millions of years ago. But they don't publicize that. You know, there's PhDs that don't know they found blood cells in dinosaur bones. Bob Enyart, he went on a cruise with all these PhDs. And they'd bring up the blood cells in the dinosaur bones, and they say, no, it's not. So he'd show them on their phone, and their mouth would drop down to the floor. It's like, what? Because they realize blood cells can't last millions of years. Therefore, the dinosaurs are not millions of years old. Therefore, that whole geologic column is just a bunch of fairy tales. And it destroys it. So they can't have kids talking about that. Also, they found olivine on comets, which was one of his predictions. And when you bring this up, you might hear some objections, like that professor. I don't believe water was inside the Earth before. Didn't believe the assumptions. It's like, you don't believe there was water under the oceans back then? Well, why not? There's water under the oceans today. Yeah, there's dark smokers there. Super hot water coming up from the bottom of the ocean. Well, if it's coming from the bottom of the ocean, where does it have to be? Below the ocean. And there shouldn't be water 5 miles deep, because granite gets so much pressure it should just be like putty. There shouldn't be water that deep. But Germany and Russia dug past 5 miles, and guess what they found? Crushed granite and water. I think it was hot water, salt water, but it validates perfectly what the hydroplate would say. The other objections are the atmosphere would have gotten too hot, the ocean would have boiled, there would have been blown the crust off the earth. Well, keep in mind this is directed energy. He's got his hands right next to that 1800 degree torch. And so air is a good insulator. Also the directed energy, a lot of that stuff just shoots out and it doesn't have any impact on our atmosphere because it gets through it so fast. It's like those Saturn V rockets. There's a lot of energy. It should have blown those astronauts up, right? No, it was directed energy. And Brian Nickel does a really good job, and we'll get to that website on answering those things. And so that's a different perspective of the Earth. My hope is that you will look at the Earth and the solar system with another perspective. How did Walt Brown come to this perspective? He was an evolutionist. He's driving through South Dakota in the 70s. Keep in mind, this is the 70s. We're on the 8th edition. How come you haven't heard of it? In the 70s, he's driving through South Dakota, and he hears on the radio that somebody claimed to have found Noah's Ark on a mountain. And he's an evolutionist. He thought, what a crackpot. There's no Ark on a mountain. But in South Dakota, there's not much to do besides count down to Wall Drug, right? And so just for boredom, I think he did a mental exercise, and he said, well, okay, if, just to humor it, if they found an ark on the mountain, that means the whole world was covered in water. That means a whole bunch of plants and animals got buried and turned into fossils. And he thought, wait a minute, if fossils are evidence for a flood, where's the evidence for evolution? And remember, he runs with those really PhD types, and he started asking them, what evidence do you have for evolution? And after 2 years of asking that question, he didn't have any. And he became a creationist. And then he put together this theory which has Bible support. It's got verses that support there's water under the earth. Psalm 136, to him that stretched out the earth above the waters. So the earth is above the waters. And this is Psalm 75. The earth and all the inhabitants thereof are dissolved. I bear up the pillars of it. So there's pillars of the earth. And that could be where the granite and the basalt are touching. And this is Psalm 24. He that founded it upon the seas and established it upon the floods. So again, it's on the water. He gathers the waters of the sea together as a heap. Notice it's waters together. And he lays up the depth in storehouses. So it's waters, and I think that's the fountains of the great deep. In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day where all the fountains of the great deep were broken up, and the windows of heaven were opened. And it's water shooting up, not magma. Catastrophic plate tectonics, which a lot of the major creation organizations teach, say it's magma. It's like, where do you get magma from that? It's water. Clearly it's water. And so it could rain for 40 days and 40 nights. And then people will say, well, Genesis is just figurative. It's poetic. It's an analogy. Look at that verse. The 600th year, is that poetic? The second month. I mean, this is historical if I've ever seen an historical verse. You know, and it's just clearly Genesis is history. And Jesus always referred to as an accurate historical event. And he's our example. If we're not doing that, we're not following the example of Jesus. And that's a whole nother talk. This is Job 38. And this is God asking Job, who shut up the sea with doors when it brake forth, as if it had issued out of the womb? And also, hast thou entered into the springs of the sea? We didn't know there were springs in the sea until 1977. How could somebody thousands of years ago know that? How could they know that? And it's like, and I think it was Isaiah where he says God hung the earth on nothing. And that's a perfect picture. How could somebody know that thousands of years ago? It had to be inspired by God. And then in Jonah it says, I went down to the bottoms of the mountains. How did they know there were mountains in the ocean? How could somebody possibly know that? And then this one, the waters, this is Psalm 104. The waters stood above the mountains. At thy rebuke they fled. At the voice of thy thunder they hasted away. Can you imagine how the sound of mountains forming? At the voice of thy thunder they hasted away. And some people say this is a creation event. No, it can't be, because they go down to the mountains, they go up by the valley into the place where thou hast founded for them. Thou hast set a bound that they may not pass over, that they may not turn again to cover the earth. Well, they covered the earth they covered it in the flood. So this is a flood event. So we're getting in the home stretch here. These are some good sources. I'll put this up at the end. Hydroplate.org, that's where you can see the Hydroplate Conference. You can see all the talks, you can see the qualifications, you can see the schedule, hydroplate.org. And then rsr.org, Real Science Radio. You can go into rsr.org, HPT will touch that, and also /answers will touch that. And if you'd rather see it visually, go into YouTube, Brian Nickel. He does a great job. And then I do what I can on Solidify Your Faith. But this is Brian Nickel's YouTube channel. The origin of radioactivity, the origin of comets, of the 90 East Ridge, of limestone, of Grand Canyon. And his Grand Canyon video is the best I've ever seen. Just clearly shows how it all happened. And you'll learn stuff in here you won't hear on the website or in class, like those potholes and that rock. And then rsr.org/HPT. That's everything Hydroplate. You get all these interviews about the Hydroplate. And it is so much fun listening to Walt Brown. Just search Walt Brown Week, and it'll just color in the details. You'll never see the Earth again the same. And then it also answers the objections. And there is a controversy. I mean, this is the 8th edition. Why haven't we heard about it? You go into rsr.org/HPT, you scroll all the way down to the bottom, and then you see Walt Brown controversy. And Jane Albright does a really good job of explaining what it is. And I was talking to Randy Gluza, the president of ICR. They're giving the Hydroplate a chance. They invited Hydroplate people to come in and show it to their scientists. He says, I want my scientists to see all the theories, right? I have so much respect for him. And I thanked him for doing that. And he said, the Hydroplate's been marginalized for far too long. And I think we need to get it out into the daylight. It's not the redheaded stepchild. It's making the accurate predictions. And if you're interested in why it was, why you're not hearing about it, go into that. And it's time to get this into the light so truth can prevail. Okay, and then we got the 9th edition. I told you how to get the 9th edition online for free. rsr.org/HPT. Scroll down to where that book is, and underneath it, it says 9th edition. You can just click on that, and you can download it, and it's all yours. And I highly recommend it because websites can be taken down at the drop of a hat. You want all this stuff, and I encourage you to get the DVDs so you have them. You don't have to depend on the internet. And then rsr.org/answers. This is where you have published criticisms of the theory, plus YouTube criticisms of the theory. Wouldn't you wish every theory would do that? You could say, this is what we believe, and this is what they say is wrong with it. You know, for plate tectonics, for catastrophic plate tectonics, for evolution. Wouldn't that be nice? You could get all the information in one website. And then it also answers to the objections. That's what I was listening to all the way back home from Denver. I was listening to Grand Canyon all the way there and the Hydroplate all the way home. And you can learn so much when you're driving. And again, here's some great Christmas presents. It's not, oh yeah, you can get a used one for $120 there. But excellent resources. I encourage you to, if you got grandkids, nephews, nieces, get this stuff because they're going to get bombarded with evolution. And if they don't know what the truth is, they could believe it. And then what can we do? You know, hopefully this isn't just information you put on the shelf and you never do it again. What we need are an army of people just throwing pebbles out there. Just throw a pebble. Go into NASA's Facebook page. Go into NASA's Twitter account and say, hey, take a listen to this comet theory. You know, let's take, would you look at this theory? What did I put? It's too bad that NASA ignored the warnings and made a catastrophic blunder. And I start posting those Hydroplate talks there. I do the same thing on Grand Canyon. You know, you don't have a theory that works, would you consider putting this one on your website? And it's not so much for the people running the site, it's more for people who are looking through the comments. And we can do that, try and do something like that every day. You get enough people throwing a pebble in there, we can make a wave that they can't ignore. Okay, so hopefully you'll have the boldness to go out there and stand up and proclaim the truth, and even go into the science departments. We have the truth. Would you look at this theory? And we're going to try and get this talk on campus. That's going to be a lot of fun. I want to keep putting that poster up if they keep stealing it. Are there any questions? I know I've gone a little bit long. Any questions at all? It's kind of, yes?
What was that site for the 9th edition?
The site for the 9th edition, it was rsr.org/HPT. Yeah, rsr.org/HPT, and then just scroll down and you see that in the beginning book, and it should be right underneath there. There'll be a 9th edition. It should be coming to print. You know, it's amazing what they do. They come out every week, and with incredible guests. After they interviewed me, they had a guy who, Carl Baugh, he found a human footprint 18 inches away from a dinosaur footprint. And so you can go into rsr.org, search Carl Baugh or footprint or whatever. It's just maybe a month or so old. He was on there for 2 shows. The second show is where he talked about it and just gave all the details, and he couldn't sleep for 4 nights because he was an old earther, and it just changed his paradigm. And now he speaks at the Grace Conference every year near Chicago in June. So if you want to see him personally, I interviewed him last time. I got a podcast. I've only interviewed 2 people, and he's one of them. And so, yeah, if you want to see him, he's 80-some years old. If you want to see somebody who actually saw a human footprint with a dinosaur footprint, he's there, and he's accessible. I do have a lot of respect for those people who stand on God's word and don't compromise. And we need more of that. We need a lot more people throwing a lot more pebbles into that pond and encouraging other people to throw pebbles into that pond. And it doesn't have to be, a lot. I mean, 2 minutes you can throw a post out there and see what happens. God can do a lot with little, but we got to give him a little. We can't give him nothing, And so I just encourage people to stand on God's word and try and influence people. And what motivates me again is I'm trying to get this theory out there before NASA makes another catastrophic blunder. I really want to get this into the mainstream. And I'm going into the science departments, I'm going into their websites and Twitter and Facebook, and I'm posting it all over the place. Because we have to throw that and realize, and I'll talk to the kids will say, well, why would somebody want to steal that? And it's like, well, it's just a guess, because if this hydroplate theory can answer all these unanswered questions, we don't need the Big Bang anymore. And we can throw it on the scrap heap of history where it belongs, and so we can have the freedom to think instead of being in the dark ages. And it's kind of interesting to see their expressions after I say that. But we plant seeds. Well, thank you for your attention. I do appreciate that.